Today we are looking at chemistry paper 3, a very important paper in chemistry. This paper is marked out of 40 marks, and we are going to start by looking at the two parts of this particular paper. Paper 3 chemistry is largely divided into two areas. One, we have quantitative, also known as volumetric analysis, and the other part is on qualitative analysis. Under quantitative or volumetric analysis, we mainly deal with titration experiments. And remember, titration is the process of running a solution from the burette to a solution in the conical flask until you observe the color change. We have three types of titration experiments. Types of titration. We have number one, direct titration. And direct titration is the titration experiment that involves an acid and a base, where we titrate one solution against another until we observe the color change. And since both the acid and the base are colorless, we use an indicator. Two, we have back titration. And number three, we have a redox titration. In a redox titration, no indicator is used because the solution themselves change color when the reaction between the two solutions is complete. We have some few questions which are normally set from this particular experiment. One, you'll be required to fill the table. And filling the table will give you up to 4 marks. And I'm going to show you the kind of table that you always expect anytime we are doing a titration experiment. Number two, you'll be required to calculate the average volume. Three, you'll be required to calculate or to tackle a question on moles. 4, you'll also be required to calculate the molarity of a solution. Remember, molarity is the number of moles in 1 liter of a solution. Then number 5, you'll also be required to calculate the concentration of such solutions. Remember, molarity and concentration are more or less the same, only that concentration is measured in grams per liter or in grams per centimeter cubic. We move down to other parts. The other part that you'll be required to tackle is on qualitative analysis. And the first thing under qualitative analysis, we are going to analyze whether a solution contains a cation or anions. Remember, cations are positively charged ions, while anions are negatively charged ions. Another thing we will be required to test under qualitative analysis. However, that is a different section, but I want to put it under this subtopic or subheading qualitative analysis. We will be doing a question on organic compounds. We will also be doing a question on solubility and the solubility curves. Apart from that, we will be doing a question on energy changes. We will also expect a question on rates of reactions. Bearing in mind that question number 1 and question number 2 tackle questions on quantitative or volumetric analysis, they can also be replaced with a question on energy changes or rates of reactions. Let us go down and start analyzing those areas one by one. I want us to start by looking at number 1. I want us to deal with the test for cations. Remember, cations are positively charged ions, and these cations are formed when metals lose electrons. The cations that we are going to test under this discussion, we are going to have the following. We have those cations that form white precipitates with the reagents that are used to test cations. We have sodium ions, we have potassium ions, we have ammonium ions. I want to group them this way because of the reasons which range between explanations and the common features they have or characteristics. Then we have the following cations. That is, we have calcium ions, we have magnesium ions, we have lead ions, we have zinc ions, we have aluminum ions, we have also another category. Let me leave this at this particular point. These ones, I have placed them together because they do not form white precipitates with the reagents used when analyzing them. We have those that form white precipitate, we call them PPTs, and we have those that have their own characteristic colors. That is, we have ion 2 ions, which form a green precipitate. We have ion 3 ions that form a brown precipitate. We also have copper 2 ions that form a blue precipitate. Those are the cations that we are going to test, and we are going to deal with each category at a time in a moment. Another thing that I want us to look at are the reagents. Reagents used to test the cations. One, we have a solution of sodium hydroxide. This one is sodium hydroxide. Number 2, we have aqueous ammonia. This is simply ammonium hydroxide. You are also going to be given either hydrochloric acid, that is HCl, or if not hydrochloric acid, If not hydrochloric acid, you'll be given sodium chloride or a common salt. We can also use what we call potassium iodide. Basically, these ones are there to differentiate between the different cations as we go down eliminating one by one until we are sure the solution contains a certain cation. Number 1. Let me call number 2 anions. As mentioned earlier, anions are negatively charged ions. The reagents that we are going to use when testing for the presence of anions: 1. We have lead 2 nitrate, solution. Number 2, we can also use barium nitrate, that is BaNO3. Remember, nitrate ions have a valency of 1 and barium has a valency of 2. These two will test for the following anions. The anions tested using either barium or lead nitrate are sulfate ions, we have sulfite ions, we have carbonate ions, we also have chloride ions. All these anions form white precipitates with the addition of either lead 2 nitrate or a barium nitrate. Number 3 reagent that you will always use to test for the presence of anions is barium chloride, or we can use lead chloride. These two will test for the sulfate ions. They will test for the sulfite ions. They will test for the carbonate ions, but they will not test for the chloride ions because we cannot use a chloride to test for a chloride. And what do you expect on addition of either barium chloride or lead chloride? You will always expect a white precipitate being formed. Then reagent number 4, you are going to see dilute nitric acid. That is dilute nitric 5 acid. That is HNO3. This one is normally used with barium chloride or lead chloride. That is, if you add barium chloride or lead chloride to a solution suspected to have either sulfite and carbonate ions, the white precipitate will always dissolve. But if that solution contains a sulfate ion, even if you add nitric acid, the sulfate ion, the precipitate will not dissolve. NB, a precipitate, is a solid that separates out of a solution. It is a solid that separates out of a solution. Those are some of the anions and the reagents that we use to test for their presence. We have also seen the cations and the reagents which are used and the expected observations.